We have here the trucks from ASL-100. These are built by the American Locomotive Company, something that Laconia contracted for. Possibly they didn't have a heavy enough truck that they were making in their own shops. We've tried to find some literature on them. We have a Laconia or a American Locomotive Company catalog, but it doesn't show exactly this type of truck. But we're going to have to assume that that's what they are. Now we've taken the motors out of these. Each truck has two motors, and as you can see they're connected by gears. This is a gear which is pressed on the axle, and then there's a small pinion that goes on the motor that runs against it. The motor sits here. These are the bearing seats. There's a brass bearing that sits here, and then the motor rests on that, and the back of the motor goes in this area. There's a bar that goes across called a suspension bar, and you can see there's springs under here, so when the motor starts up it has a little bit of a cushion and doesn't jerk. And the motor, this is what they call an inside suspension. That is, the motor is on the inside, and the rather than some cars which they put it on the outside, and that would put the wheels closer together. The reason they put it on the inside is so that you have a long wheelbase, and the motors don't have to have terribly long leads to connect them to the up in the body. The motors themselves are now taken out, and we'll look at those later on to see what we found. What we found in this area was quite good. The brass bearings, all of them, all 8 pairs of them, are in good shape. They look virtually new, and will need nothing more than cleaning up and possibly a little bit of improving of the oil grooves. And we can look at those later on. They're next door. We can show a picture of those. Now, the trucks themselves are composed of a set of wheels and axles. This is the wheel and pressed on an axle. All of this comes as a unit. This is number 3, 4, 1, 2. We've numbered them with this sophisticated system of painting a number on it just so we can keep everything together. What we will ultimately do will be to lift the frame up, take the wheels out, and put them in storage, putting rust coating on the journal, these polished surfaces, so that they don't rust and get rough. There's also a journal surface inside of that journal box, which is in the end. There's a bronze bearing in there that the truck actually rests on. And we'll protect all those, and the wheels will go out, and we will probably do nothing more to them. These wheels are somewhat worn. This one is fairly good. You can just see what they call a double flange starting to form. In other words, when this was turned out, this came from the last time it was put on a big lathe, and they would turn a proper contour. You've got the flange and the tread. That this was tapered down slightly in this direction, which keeps the wheels centered on the rail. As the brake shoes wear against here and on the rail, as it runs on the rail, they tend to wear down this way and get what they call the start of a double flange. This one isn't too bad. I think this one shows it maybe just a little bit more. We thought, well, should we have these wheels turned or replaced? And we've decided we don't think we will, for a couple of reasons. Initially, we looked at that and we thought, gee, that's pretty thin. There isn't much left. We really probably can't turn this down anymore, because when they do profile a wheel on the lathe, they'll just come in here with a big cutter, and it will take off as much as a 1/4 inch, and you can see there'd be very little left of this. So, considering the amount of time that number of miles that this is apt to run over the next 1,000 years, we don't think it's really necessary to do that. These wheels have a little bit of an interesting contour. On the back of them you can see some spokes-like things that are cast, and that's unusual. So there's no point in making problems for ourselves. So the wheels we're going to leave as they are. The axle should be fine. The axle collar, which keeps the motor in line over there against that wheel, looks okay. Now, so we would remove that, and then we're left with two essential things. One is the truck frame itself, and then the other is the brake mechanism, which is hung from that. This is what they call an arch bar truck. You see a bar which arches like that. It's a very simple thing. It's not meant for comfortable riding so much as it is, the springs help the truck conform to irregular track configuration. There are some springs in it. There's a coil spring here. There's a leaf spring here. The leaf spring holds the bolster. The bolster is this thing that goes right across the car here, and it goes up and down as the track of the car bounces on the track. There's a center bearing. This is the female, what they call the truck center bearing, and then there's a matching nail part that sets down in that's on the car, and there's another bolster that goes on, which is part of that's fastened to, that goes across underneath. The truck has this frame which goes all the way around on top, which everything's bolted to. It has these big things called transoms. They're quite large channel, half-inch thick, I believe it is, and about 10 inches, half-inch by 10 by 4 inches. And that's the major structural part of the truck that holds the whole thing together. The brake rigging hangs from the truck itself. You can see this is what we call a brake beam that goes around like that, and you can see the brake shoes, one on each wheel, that press against it. When you pull on this lever here, everything moves toward the truck, and it pulls the brakes on tight. Looking up here, let's move this thing out. You have what's called a radius bar, and in the center of the locomotive is a lever that operates like this, and it's operated by a pneumatic brake cylinder, and that pulls against here, which pulls against these. This has gotten bent over time, which pulls the shoes against the wheels and applies the brakes and slows the car down. When the brakes release, these springs pull it back and release them. There are swing links here that hold it. There's a brake shoe head and the brake shoe. Now all 8 brake shoes are usable. I see one that's got a crack on it, but it's not bad. These levers and pins and so forth are worn. We will replace the pins, no doubt, and maybe put some bushings in so that there isn't so much slop, because every bit of slop adds up, and the next thing you don't have any brakes, because when all you're doing is, when you pull them on, is taking up all the slack, and then there's nothing left to actually pull the brakes on. Oh yes, I didn't mention this. This is called a side bearing. You have a matching pair of these on the side of the car, and so when the car does this, it rests on here, and as the truck turns, these and the one on the body slide on each other. The bolster is sprung by the leaf springs that we mentioned on the end, and you have what's called a swing link here and here, same thing on the other side, and that allows it to swing slightly back and forth, again helping it conform to the ride. Now this is under tremendous tension. The springs are pushing up on this, so when you have weight on it, the weight of the body will push down on it, and when we take this off, which we're going to have to do, and I'll explain why in a minute, we have to put something to keep this down, otherwise it will explode when we take these bolts off. And so we put a chain around it and a jack and put a lot of pressure till it goes down slightly, and then we'll take these off and let it up gradually. One of the things we found as we look at this is one of these trucks was, I think, received some attention rebuilding, and the other one has not. But one of the things we found is a great deal of rust in these. I mean, there's the obvious just rust lying around and everything, but even more so, we find it, let's see, where does it show up really? I think the other truck we show up more. This isn't quite so bad. But wherever you have two steel surfaces together, any moisture that gets inside there will start rusting, and the next thing you know, you have things actually pulling apart just from the force of the rust, sort of like a tree branch in a rock when ice, or the tree root in rock, or ice that gets into rocks and splits them. Let's see. You can look in here, I think, how much that'll show. One thing I didn't mention, the journals are packed by wool waste in there. Well, that wool waste is turned pretty much to stone. It's not much good. It's wool saturated with oil, so we'll have to replace all that when we take it apart. We have some rust on this spring seat here, which is water's gotten in there and cracked the bottom of the case right away. That will have to be replaced. Let's look at the other truck. I think you can see that this one's a little bit worse. Yeah, you can see it right here. There's what we call necking down has occurred right here. Water has gotten here and this bolt has rusted away, so instead of being this big in diameter, the actual effective part is only that big. And so that bolt essentially, instead of being a 1-inch bolt, is really about a 3/4 or even half-inch bolt, and we're going to have to replace a lot of these. You can see up on top what's happened to some of these bolts. They've rusted away very badly. And we see a lot of rust all through the truck. You can see piles of it on these transoms. Now, these are highly overbuilt, and we're not going to put this in heavy service, so we probably won't have to replace a lot of this stuff, except for the hardware, which I'm concerned about. We found that the bolts tend to crystallize. They've lost a lot of their original strength, and you can see right here that there's a piece of 5/16 to 3/8 steel. It's almost gone here. So we take these off and replace the hardware over time. And that's a lot of beating and banging and heating and so forth that takes to do it. We will probably, like a piece like this, which is for the adjustment on the brake lever, we'd probably cut these ends off and weld a new part on here and preserve as much as we can of the original. And that's something that we will say time and time again. We'll preserve as much of the original as we can, because some of the materials are hard to get, and different shapes of hardware they don't make anymore. But on the other hand, if something's going to fall apart, there's no point in putting something on it that's not going to last. These motors are a series motor. That means that your electrical circuit goes through the armature, which is the part that turns around, then through the field coils, and then back from the power station to the ground. And a series motor has no top speed. In other words, if we were to plug these motors into 600 volts right now, they would just go faster and faster and faster and eventually blow up. However, with a trolley car, there's a certain advantage to a series motor. It has its maximum torque, turning power, at 0 RPM, which is when you want it. When you're starting the train off, when you're starting the car off, that's when you need the most force. So how do you prevent these from blowing up? Well, it's very simple. You have a gear, which is a pinion rather, this is the small gear, which is directly connected to the ones that we saw on the truck. That's a permanent connection, and so therefore you have, unless something goes wrong, that motor will be kept from going at its maximum speed. In fact, it'll go faster and faster until it reaches what they call a balancing speed, which is the friction of the bearings and the wind resistance of the car hold it to. That Locomotive 100 might have gone 25 miles an hour. I'm only guessing. But speed wasn't what they were interested in. It was being able to pull 4 or 5 box cars around. So here is the pinion which runs on the gear. Now we found that the gears and pinions are in excellent, like new condition. Those pinions operate, and the gear goes here, operate in this gear case. There's another half of it, which is next door. And this black stuff is a gear lubricant called Crater, or now it's called traction motor gear lubricant, which is basically the last thing in the refining process next to road tar. And they want something that will stick to these gears under the high pressure that they have.
How much do these motors weigh?
These motors weigh 2,450 pounds without the gear case on them. Just that much, what you'll see around here, just a little over a ton. These are, for 40 horsepower, these are rather large. If they were to build a 40 horsepower motor today doing the same thing, it would be probably 1/4 the size of this. And the reason these are so large is because they hadn't figured out, they needed to keep them waterproof. The early motors were called a WP type, waterproof, because the oldest ones just ran everything exposed, and of course when it rained or slush and so forth, you had a real problem with, they didn't last very long. Then they put a case around them, and then they finally made these watertight. However, they hadn't figured out how to ventilate them, and these motors get warm, especially when you're pulling a lot of load, and they took care of the heat dissipation by having this massive heavy case here, and that soaked up the heat, and then it gradually went out into the atmosphere through the size of the case. So there's a lot of room inside of them, which you'll see in a minute when we look over at the other motors, and a lot of mass. And then gradually over the years they were able, number one, they could wrap the insulation much tighter, the wires much tighter, the insulation was better, they didn't need as much, and they could shrink them down inside. In 1904, when these motors were invented, this was as good as they had. And so these are rather large and rather heavy motors, help put weight on the wheels, which helped the locomotive have traction power, but it made them rather large and for us kind of heavy to move around. Now what we have done is we pulled the motors out using the pettibone lifter. They were over on the pit, and the bolts that you see here now, these motors are upside down. So we had to get at a lot of these bolts from the underside in order to get them off of the axles. We then brought them around outside the shop, brought them all the way around and back in here, where we then turned them upside down and loosened a lot of the bolts. We found that many of these bolts probably hadn't been loosened for ever, 50 years or something like that, or maybe more than that. And a lot of them were rusted in place, and we had to heat them red hot, and then with a large wrench and hammering on a wrench and so forth, we were able to loosen most of them. The ones that we couldn't loosen up, with a cutting torch we would slit here and here, and we were able to knock the nuts off, and believe it or not, even with a cutting torch, the threads were actually not bothered, and we're going to restore many of the bolts. They're not a high strength bolt. What they did in the old days is they made them thicker with heavier nuts than you would normally use for the same purpose now. These are coarse threaded ones. They would use a fine thread now and a grade 8 bolt. I don't know what grade these would be equivalent to now. But we hope to use most of them over again, and so we're rethreading them and basically bringing them back to usable purpose. Now the motor, it's a split frame motor. This is upside down. There's a top down here and a bottom, and this is meant so that in the pit you could swing this down. There was a nut here and an eye bolt here, and on the other side also. So this was the hinge side, and with a jack underneath it, you let the bottom down, and then you could get at the inside of the motor. And then if you needed to, you could take the armature off. Now, you can shine over here on this one. This is, again, upside down. I'll get on the other side. The armature turns around inside of here, and it's held by these two saddles. There's one here, one that's removed there, and you can see on that one there's a bronze bearing inside of there. There's another one inside of here. And with this is, imagine this again, upside down. You take this off, take the other one off, have a jack under here, and you can let the armature out. Now that's easy to say. It takes an awful lot of work, and what we found that some of the bearings, the bolts rather, were very, very tight, but eventually we got it apart and were able to let it down. Now this armature is composed of a shaft that goes right through. You can just see the end of it over here. And on this one, here's the pinion, which is pressed onto here. What they do is they heat that. We put them in boiling water so that it slightly expands, drive it on this tapered fit with a lead hammer, and let it shrink, and it will stay right in place. However, we found this one was loose. There's a big nut on the end of the armature that goes right on here that's supposed to hold it in place, and it did, thank goodness. But the pinion itself was loose, and it just fell off as soon as we took the nut off. The one for this next one over here was very, very tight, and we had to take it off with a device that looks like, turn right around, like this, and I have some pictures of that. You can see it operating. It's basically like a champagne cork puller, goes over the gear, and then you turn it up tight, and you take a big sledgehammer and whack on the end of it as hard as you can, and after doing that for about a half an hour with heat and tightening, it eventually pulls the thing off, and it comes off with a snap. Now, getting back to the armature itself, there's a bearing inside of here and a bearing on the end. This is called the pinion end, and this bearing's a little bit bigger, and it has a lot more force on it because it has the gear which is tending to push apart, and it wears quite a bit. And we, just for assurances, yesterday we measured the clearance on this, and we found that this one was about almost 3/8 or 5/16 of an inch. It's supposed to be 15 thousandths. It was 300 thousandths. So as you can see, that's
clearance where?
That would be between the edge of the bearing. Now,
so be easier on this one here?
Well, no, you can see it. What you'll have to do here, you can do it right here.
All right.
You get right. No, it doesn't show. This one's pretty good. All right, I don't know whether you can come around. You probably don't have enough cord to come around to do it.
Yeah, I do. If you take the light,
yeah,
we can
something to stick in there that shows that.
All right.
Here's the shaft. There's the screwdriver. That goes right in there, and there's plenty of room to spare. Now, that should be 15 thousandths of an inch, maybe less than that. And so what's happened is this wore over the years. This is a bronze shell. There, see the bronze? With a material called babbitt. And babbitt is basically a tin and lead soft material that cushions that will, if there's any irregularities, it will conform to them. Well, that babbitt has worn and worn and worn away from its original thickness down to nothing and created this space. Now, we're upside down, so that space would normally be down here. And that has got to be replaced, because what's happening is that as the bearing wears away, the armature gets closer and closer to this, what's called a pole piece. This is the field coil, which has many, many turns of wire. And that's basically the magnet that interacts with other wires that are inside of here that makes it turn. Well, you can see there's absolutely zero clearance there. This is rubbing right against it. So if this was to turn, this would scrape, tear this all up, and eventually the motor would blow up on here. Now, one thing I found, right here enough, was there were a couple of shims here. There was a piece of metal here and another one here. And what they had done to cheat a little bit in Sanford was they put them there so that it spaced the motor slightly apart, and that way it wouldn't rub, but it wouldn't last very long. So we're glad we caught this. We found this motor was extremely bad, the other one was close. We've measured 2 or 3 of them so far, and they're basically going to have to be rebabbited. We just had a man from the AC Electric Company here, and he gave us some ideas as to what we would do. There's a company down in Georgetown, Massachusetts that will rebabbit these bearings, and hopefully it'll be a reasonable cost. Now, what is next on these is we've taken these apart. He looked at them and he said, "You've done what you should. You've made it easy for us," because they will then clean them up. But the hard part was taking them apart, taking these very nasty bolts apart and so forth. And then we will put them back together and they will take them up to their shop either in Lewiston or Bangor, depending on the type of work they do. And the first thing they'll do is they'll take the armature out and they will clean it very thoroughly, steam clean it, bake all the moisture out of it, and clean off the bits of rust that they see here, and then they'll impregnate it with a varnish that will seal the moisture out. And there's a couple of different processes that they will do. One will be just to spray it on the outside, which I hope which is okay, but not really the best. And the other is what they call vacuum pressure impregnation, VPI, where they actually they will put this in a vacuum, and then they will introduce, while it's in a vacuum, they will introduce a special resin to this. It will be sucked in by the vacuum, and that's the best, and then they'll bake it so that it will dry. However, because this is old and dirty, they may not want to risk the quality of their varnish, which is some huge amount that they have an investment in that could be ruined by dirt from this, so that's something they'll evaluate. They'll also take the field coils out and either re-insulate the outside of them or dip and bake them separately. We will, when they go up there, they will evaluate all of this stuff. Something I forgot to mention, there are armature bearings, or axle bearings rather, that go in here. You can just see this. This is wool waste that I've got my finger against, and that presses against up through a hole in the bearing against the shaft of the axle of the motor, which goes right here. So again, we're upside down. You have to imagine the axle turning around here, and this is how the oil gets at that. That's a very small opening. It's an obsolete design. It really doesn't work very well, but we have to use it. I think that's all I can think of. These motor goods are used by this local rodent population for winter homes, and I found, I'm taking an access hatch off. I think I've got the right one here, and I found inside that, and I don't know how they get into these things, but there is what we find quite often in motors. This is a squirrel's home here. You can see it's made of cotton, which I think they get out of the seat, the upholstery of some of our cars, and they diligently carry it up into these motors, and then they put it here. Well, of course, you can see if we had any sparks in there, we would have a fire, so that's not very good. So obviously we'll take that out. I just left it there for educational purposes. Now, this motor is upside down. We're lifting, this is what they call a split frame motor, so we're lifting the bottom half off. It's easier to do it this way than it is to have it right side up, lift the top off. And this is meant so that you can take the motor, if this was the other way around, you could drop this bottom half in the pit without taking the motor out from under the car, or having to jack the car up. I don't know where this is balanced the way it is. Now what I'm going to do is, and I may need your help here, is to set this down in the middle of this area here. Alright, what you're looking at this is a pair of what they call axle bearings. This happens to be for motor 1. And you can see how they go through how the axle would go through it. And this is the opening through which the waste is packed. These are put in I'm not sure I can get that loose. This is one that's still in what they call the axle cap. This bolts onto the rest of the motor frame with 3 different bolts here. And then you can see where the waste is. Now this is a system that didn't really work very well. If you look at the waste, you see it's not even pushing up against the axle. There's no way that the oil can transfer to this except down from the top through the very small openings. This is In fact, some of our cars, these have been closed right off. I don't know what we'll do on this one. We'll think about it. This bearing it has to be split in half because you have to drop this down in order to get it off the axle and to get the motor up. This is what we had to take off to get the motors apart. You can just barely see this hole here and a little bit of a pin. This is supposed to remain still, and but what happens is it works back and forth and gradually enlarges the hole and the anchor pin here. So that's going to have to get filled in, and then we can put this motor back in service, and this bearing is fine. There's plenty of wear left in this. Now, I don't know whether you can get this or not. Can you zero right in on that? That says J.F. Hodgkins Company, and somewhere else it'll say Gardner, Maine. When we were doing our car number 38 back in the 60s, one of our members, Tom Brigham, discovered that, and he called Mr. J.F. Hodgkins of the J.F. Hodgkins Company, and Mr. J.F. Hodgkins, who was in his 80s at that point, came down and was very impressed to see that people were still using his bearings. And as it turned out, we bought a number of bearings from them before they finally went out of business, because bronze casting is something that's not done much anymore because of a lot of the environmental regulations. But here, these will be cleaned up and these will be just fine, and we'll use them for many, many years to come. They weren't all... Yeah. Oh, there's the Gardner. Okay, there it is. Yeah. Yeah. Oh, I messed it up.
That's all right.
Huh. It does say Gardner, Maine. This one might be a little clearer. There were some made by a company called Brady. I don't know. Yeah. I could take one of these in and put it in the...
All right.
We have taken all of the tongue and groove red oak decking off, and it was nailed down with about 4-inch long common nails into the sill, and those nails have rusted over time, and as a result were somewhat difficult to pull up. Fortunately, every piece came up more or less whole, and we've evaluated whether or not we want to reuse them or not. And we've come down with, we're going to try to preserve as much as we can, because it, number one, is expensive, number two, because it is part of the original car, and number three, because we didn't, most of them, or many of them, got saved to the point that they will be usable. And also they have certain wear patterns, which I'll point out, that are part of the car. And in the case of the hoods, they're hidden anyway, so appearance is not as critical. From what I can tell, they never were painted. I'm not sure what we're going to do for a finish, if we may put some kind of a preservative on them. Now we're looking at hood number 2. This is the number 2 end. And these are well saturated with oil because the air compressor sat right there, and they oiled it well, and that oil leaked through this, and essentially this wood, almost all of it, is just about as good as the day it was laid down, except that it was somewhat cracked in taking out. I don't know whether there was ever, this is a slight aside, I don't know whether there ever was a second type of air compressor or not. I tried to find some holes that might indicate that, because the original air compressor was located underneath, but for right now all we have evidence of is the CP30, which is what the car had. So anyway, we've just placed an order with Barnstormers, and we are going to order some new decking, enough to do maybe this much, and we'll piece that in here and there with the original decking. How it's going to lay down is we'll have to see. They're going to, we've made a drawing of the tongue and groove that's on the end here, which we think is probably a fairly unique cross-section, and they'll probably have to make new knives for us for about $300. The knives will be then what they will use to mill the edges. We do have to have new decking for the outside. That was replaced by Seashore long ago, and so we will definitely have to use it there. But what we use here, we'll use, at least in this hood, I think we'll be able to use all of these pieces. Now, getting back into the cab, you have to use your imagination. We've essentially got 5 spaces. You've got the deck on either end, you've got the hoods on either end of the cab, and then you've got the cab. So we're treating each one of these areas separately, even though I think originally the same decking went from one end to the other. Though on the decks it went fully out to the end. In this area right here, it went only about 4 inches from the outside, and then they had another piece running along here.
I have to have you stop for a minute. Okay.
All right. We're now in the cab area, which is about 8 feet long. And you notice right here, there's a space. The original boards are back here, but apparently they had a rot problem in the doorway, and I don't know whether it was Seashore or York Utilities, but anyway, this was pieced in with some thinner stuff. They had to shim it up so that the top matched. And so we've taken that out, and what we're going to do is we're getting, as I said, some of the earlier, or this original cross-section we're going to have made, and we'll piece in there. If you look across, now maybe you can get your light shining that way to get the cross-section. If you look at a low angle, you can see the wear patterns where the operator stood. The controller was over on the far side, and then the handbrake was closer here, but where he stood was primarily right in that area there, and you can see how much was worn away. Yeah, I can move.
Yep, no, I can see it pretty well.
Okay,
yep.
So we're going to try to save those. I don't know about this piece here. There's the patch for it with some nails and glue and a little epoxy filler. We'll be able to make that so it's usable. It's not, you're not going to fall through. It's first of all, the sills are close together, and second of all, this is 2 inches thick oak. So that way it's quite strong. For whatever reason, it split over the years. Probably some was in pulling up, but also the stuff shrank. And I think because of the way the nails were on, you had one on either side of this, and shrinking it tended to pull away from that. So here we're now beyond the door. We have the full length right here, and these pieces are pretty good shape. A little bit of rot around the doorway here, and then the same thing on the other side and the other doorway. And then down here we're at, this is now end number 2, so you've got the controller here, and quite long.
I got it.
Just move it to one side. Yeah, this you can see the pattern quite well. The wear pattern.
Yep.
The controller sat right there. These are where the air pipes went down in the corner. This was a space they had because 2 air pipes went down through here. So this stuff is, the more I look at it, the more I think I can use it again. How we're going to integrate the new stuff into it, we'll figure that out. There was a frame all the way around the cab, which was made of this 3-inch square ash. There's a piece that went here, this went all the way around. And we've saved a couple of pieces just to see how that's made. Obviously this one is going to be a little bit hard to use again, so we won't use that. Now we're out under hood number 1, where the grids were. And this stuff is, again, pretty good. The more you look at it, the better it seems. And even these ends are bad, but they're out of sight and well protected. So with the exception maybe of this piece here on the end, we will probably be able to use all of that. And then finally from here on out is the rest of the deck, which is brand new. What I don't know exactly how we're going to do is you got the end of your rope?
Yeah, I gotta
Okay,
breathe. All right.
As we look across, these sills are somewhat uneven, and we're going to have to come up with a straight pattern here. Some of it is because, especially the one in the center, got bent down because that was the force that the coupler was fastened there. Then we also have these shims which were put on by York Utilities at some point, the bolster shims here. And we've got to get those so that everything is level. There'll have to be a certain amount of cutout in the back of the floor, or set this down just a little deeper. As I look at this one, there's a little rust in back of that, which is probably why it's high. So we'll have to work all that out. Now, this end is the one, this is the number one
Yeah,
end.
you got your light, you gotta step over that if you're coming up to the front. Yeah,
This is the number one end, from which the sill was removed long ago by Seashore apparently when they did the sill on the other side. And the tenons are sort of here, but we're going to have to make some new tenons. And this center area here, this is the worst one. We're probably going to have to piece on both sides of this. This took all the grief when the coupler was banged into and when it pulled and so forth. So this will be the challenge, but the others are pretty good one way or another. We'll probably take off this splice because we want to run back a little further, and but we'll do it the same way, at least as I envision it. We'll do it the same way as they did, hold on a new piece with epoxy, but here we're going to have to put another tenon on. Over here, I don't know.
when?
All right, we're at the number two end now, and this is the end that still had remains of the sill on it. And fortunately, all of the tenons were preserved. You can see, if you compare this with the number one end that we looked at earlier, this is much better shape. They've had to do a little bit of reinforcing on it, but we can save most of this stuff here. So these are the ends of the rods that the coupler fastened onto. Over here on this sill, we still have this little tiny bit of a tenon, which apparently was all that there was on here. We'll probably consolidate this, clean it all up, and consolidate it with some epoxy to make it stronger. Okay, I think that's all we need there. Here's the remains of the end sill assembly. Just enough to get the cross section on the end of the top piece. This is the end sill, the pilot bracket, and then down below here is another coupler reinforcement. These are the bolts. They're 16-inch long by 3/4 inch going through, and these are here only as a pattern and as a hole spacer. Interestingly enough, this particular piece, the pilot, I call it the pilot support beam, was in practically perfect condition, and the reason was because I think it's a railroad tie, and it had creosote in it, so it was well preserved, as was the piece underneath. Unfortunately, it got split, so I think I know we're going to replace it. We just ordered it. Interestingly enough, also in the back, you can see the tenons. There's no question about the measurement for our bolts and so forth, and the size of the tenons. You can even see the layout marks made by Locomotive craftsmen many, many years ago as to where they were going to put these holes. So, that's the rest of the story, however you would say.